Let's do some examples with logs of arbitrary bases, just to refresh ourselves on the properties. The first one is log base a of 1 over a squared. So the way we want to do that is we want to exploit the properties of logs that we know. So what we can do is there's a couple of ways to do this, but one way I'll just do this is that we have a quotient. So we can say that's log base a of 1 minus log base a of a squared. And log of any, it doesn't matter what the base is, of 1 is always 0. And then we have another property that says that we can take that exponent and we can bring it out front. So that's minus 2 log base a of a. But we also have another property that says that if the base and the argument agree, that that's just a 1, leaving us with an answer of negative 2. Now our next piece is log base 8 of 4. Now this one's a little more complicated because if we want to do this without a calculator, we need to exploit some of these values of a log. I need to figure out some way to get an 8 even though I only have a 4. So let's think about this for a moment. What I can say is, okay, 4 is 8 divided by 2. 4 is 8 divided by 2. Alright, so then I can say that that's log base 8 of 8 minus log base 8 of 2. Which gives me 1, because the base and the argument agree, minus log base 8 of 2. And you might think to yourself, well, that's not any more helpful than starting with 4. And that's probably true, but think about 2 and 8. So 2 times 2 times 2 is 8. So if 2 cubed is 8, then 2 is the cube root of 8, which also means that 2 could be rewritten as 8 to the 1/3 power. Okay, so that means we have 1 minus log base 8 of 8 to the 1/3 power. Now again, we can use the power rule for logs to bring that to the front. And we find that when the base and the argument agree, you just get a 1. So this is 1 minus 1/3, which is 2/3. Okay, so that's one way to do it. The other way to do this is to recognize that 4 to the 3 halves is 8. So 4 is 8 to the 2/3. But that's a little harder to recognize. I mean, this is maybe not super easy, but I don't know that a lot of people recognize that off the bat. If you did, you could kind of short circuit all this and jump straight to that, but that's kind of difficult. So continuing on, we have log base 10 of 100. So what we want to do is we want to do the same thing. We want to say, how can I represent this as some sort of power of 10? Well, that's fairly straightforward. We say that's log base 10 of 10 squared. So we bring that down, say 2, 10, 10. Since the base and the argument agree, that log becomes 1, so our answer is just 2. So that's really clean and straightforward. But this one may be a little harder to think about. So 0.0001. Well, let's see, that's 1/10, 100th, 1,000th, 1/10,000th. So if it's 1/10,000th, okay, 1/10,000ths. So that is log base 10 of 1, or 10 to the 4th. Now remember, when we're dealing with tens, you just count the number of zeros, and that's your power of 10, right? 2 zeros, 10 squared, 4 zeros, 10 to the 4th. So there's two ways to do this. Let's kind of branch them out. The first one is to rewrite this with a negative power. We could say log base 10, 10 to the negative 4. So then we could use the power rule to bring negative 4 to the front. And the answer is -4 because the base and the argument agree. So that's one way to do it. The other way is to use that quotient rule. So you say log base 10 of 10 of 1, log base 10 of 1 minus log base 10 to the 4th. That's 0. We can use the power rule, and then that's just 1, so -4. So either way you do it, it's the same idea. But that's kind of a refresh of log rules, and hopefully you feel more comfortable to engage the next parts.